Hi, my name is Olga, and I would like to present the second part of the recommender clustering. In this part, I will talk about the hierarchical clustering as one of the main methods of clustering analysis applicable to recommender engines. First of all, I would like to discuss the concept of hierarchy in general. Both the natural and human-made world contain many examples of organizing systems into hierarchies. By organizing information into a hierarchical structure, you can build an intuitive structure out of your data that demonstrate explicit nested relationship. Through the use of similar distance metrics such as the Euclidean distance from k-means, we can develop a tree that shows the many cuts of data that allow user to subjectively create clusters at their discretion. Imagine that you were simply presented with two features of animals, their height and their weight. Since you are only given animal heights and weights, you won't be able to extrapolate the specific names of each species, right? However, by analyzing the features that you've been provided, you can develop a structure within the data that serves as an approximation of what animal species exist in your data. And this perfectly sets the stage for an unsupervised learning problem that is well solved with hierarchical clustering. In the plot, you will see the two features that we created on the left, with animal height in the left-hand column and animal weight in the right-hand column. This is then charted on the two-axis plot, with the height on the x-axis and the weight on the y. As we see, this cluster represents dogs' height and weight, and this cluster represents cats' weight and height. Then we plot data on the dendrogram plot, and once you have this dendrogram structure, you can interpret how the data points relates to each other, and subjectively decide at which level the cluster should exist. If you were just interested in grouping your species dataset into dogs and cats, for example, you could stop clustering at the first level of the grouping. There are two types of hierarchical cluster analysis, agglomerative and divisive. One way to approach hierarchical clustering is by starting with each data point serving as its own cluster and recursively joining the similar points together to form clusters. This is known as agglomerative hierarchical clustering. We will use Euclidean distance to determine the similarity between the records in our dataset. Eventually, by grouping individual records from the data with their most similar records recursively, you end up building a hierarchy from the bottom up. The individual single-member clusters join together into one single cluster at the top of our hierarchy. While this is typically the most common approach for this type of clustering, it's important to know that it's not the only one way a hierarchy can be created. The opposite hierarchical approach, that is built from the top down, can also be used to create your taxonomy. This approach is called divisive hierarchical clustering and works by having all the data points in your dataset in one massive cluster. To understand the intuition behind the agglomerative and divisive, let's imagine that you are an entrepreneur who just bought a new grocery store and needs to stock it with goods. You receive a large shipment of food and drinks in a container, but you've lost track of all the shipment information. In order to most effectively sell your products, you must group similar products together, right? And setting out on this organizational goal, you can take either bottom-up or top-down approach. On the bottom-up side, you will go through the shipping container and think of everything as disorganized. You will then pick up a random object and find its most similar product. For example, you may pick up an apple juice and realize that it makes sense to group it together with orange juice. With the top-down approach, you will view everything as organized in one large group. Then, you will move through your inventory and split the groups based on the largest differences in similarity. For example, you may originally think that apple juice and tofu go together, but on second thoughts, they are really different. Therefore, you will break them into smaller, dissimilar groups. Okay, now let's recap the steps to perform hierarchical clustering. Given n sample data points, view each point as an individual cluster with just that one point as a member. Then calculate the pairwise Euclidean distance between the centroids of all the clusters in your data. Group the closest point pairs together. Repeat step 2 and 3 until you reach a single cluster containing all the data in your set. Then plot a dendrogram to show how your data has come together in a hierarchical cluster, and decide what level you want to create the clusters at. Now let's look at how to perform hierarchical cluster analysis in R. First of all, we compute distance applying Euclidean distance measure and using dist function. Then, to apply hierarchical clustering analysis, we use hclust function and parameter method. Method in this case means linkage, which is the concept of determining how you can calculate the distances between clusters, and is dependent on the type of problem you are facing. There is a choice of types of linkages. The most common are single linkage, works by combining clusters based on the closest points between the two clusters. Complete linkage works by combining clusters based on the furthest points between the two clusters. And centroid linkage works by combining clusters based on the distance between the centroids for clusters. Determining what linkage criteria is best is heavily dependent on your particular data set. For example, single linkage will not be affected by distant outliers. Conversely, complete linkage may be a better option if your data is distant in terms of intercluster. Centroid linkage falls apart if the data is very noisy and there are less clearly defined centers of clusters. Typically, the best approach is to try a few different linkage criteria options and to see which fits your data in a way that is most relevant to your goals. Then we plot the dendrogram and make a decision on cluster level using cut tree function. If we compare agglomerative and divisive methods, we should say that due to the greedy nature of agglomerative, it has the potential to be fooled by local neighbors and not see the larger implications of clusters it forms at any given time. On the flip side, the divisive approach has the benefit of seeing the entire data distribution as one from the beginning and choosing the best way to break down clusters. This insight into what the entire data set looks like is helpful for potentially creating more accurate clusters and shouldn't be overlooked. Unfortunately, a top-down approach typically trades off greater accuracy with deeper complexity, and in practice, an agglomerative approach works most of the time and should be the preferred starting point when it comes to hierarchical clustering. However, if after reviewing the hierarchies you are unhappy with the results, it may help to take a divisive approach. I think it's time to compare k-means and hierarchical clustering analysis for a recommender system. Hierarchical clustering benefits from not needing to pass an explicit k-number of clusters, and this means that you can find all the potential clusters and decide which clusters make the most sense after the algorithm has completed. At the same time, k-means clustering benefits from a simplicity perspective. It can be explained to non-technical audience but still be accurate enough to generate quality results. In k-mean method, instantiating random centroids and finding the closest points are time-consuming, or even it may never get to that point. So hierarchical clustering is less prone to this weakness. Also, in hierarchical clustering, clusters can be subjectively chosen through the evaluation of a dentagram plot, which is obviously a big plus. Okay, let's conclude. Clustering is a widely used method in recommender systems. One of the way to make recommendations based on past purchases of other customers is to cluster customers into categories. Each cluster will be assigned typical preferences based on the preferences of customers who belong to the cluster. And any new customer that shall be classified as a member of cluster will receive recommendations based on preferences of the group. So we need to remember that clustering works at a group cluster level, unlike collaborative filtering, which works at the customer level, or association rules, which works at the item level. That means that clustering methods usually produce less personal recommendations than other methods and most often lead to worse accuracy than nearest neighbor algorithms. At the same time, clustering techniques work faster on aggregated data. Also, we can benefit from combining clustering method with collaborative filtering algorithm, shrinking the selection of relevant neighbors. So basically that's it, and thank you very much for your attention.